Hello, everyone, and welcome to the 2023 CINR webinar. Next, we're going to cover topic area 6, licensing and safety. And right now, Janelle Edens is on, and she's going to introduce this topic. Go ahead, Janelle.
Hi, so good day, everyone. My name is Janelle Edens, and I am the Federal Point of Contact for subtopic LS4. We also have on the line William, Jason, Savannah, and Tanzel, who will walk us through LS1 through 3. And then in addition to the federal program managers, we have our technical experts from the national labs who will be available at the end of the session to help answer any questions that you may have. And since this is the third day of the webinar, you're probably familiar with the process by now. But if this happens to be the first session that you're joining, we're going to walk through each of the subtopic areas and then take questions for each of the subtopics at the end of the session. Next slide, please. So this slide provides an overview of topic area 6. And this topic area is focused on licensing and safety considerations for the existing fleet, as well as future advanced reactors and all fuel cycle related facilities. And as we look towards the current and future goals for nuclear energy, there continues to be a need for enhancing understanding of licensing and safety requirements as they apply to the safe and secure operations of nuclear reactors and fuel cycle related facilities. So there are 5 subtopics within this topic area which cover a variety of high priority needs. So I won't spend any more time on this slide. Let's get started with LS1, which is being led by William Walsh.
Thank you, Janelle. So hello everybody. My name is William Walsh, and I am the program manager for the Light Water Reactor Sustainability Program. And I'd just like to give a brief background on the program before jumping into the topic area. So the goal of the program is to extend the life of the commercial light water reactors in the United States. And we do that in a couple ways. The first is ensuring the safe operation of the physical components of the plant, but then there's also an economic pillar or economic direction that we take through lowering operations and maintenance costs, and then also diversifying the revenue of the plant. And so there's several research and development areas within the program. The one I'll be focusing on today is risk-informed systems analysis. And then as a subset of that program, we also look at probabilistic risk assessment methods, which serve as a fundamental element of nuclear plant operations and regulatory infrastructure. Specifically the NRC's reactor oversight program. And so PRAs are used for compliance activities, regulatory compliance activities, but they're also used by the plant to do things like prioritize maintenance activities. And so many regulations and plant operational procedures in the past have been based on very deterministic and prescriptive requirements. And in general, the industry is moving more towards applying risk-informed approaches to compliance activities, but also just plant operation and maintenance procedures. And so as more applications arise for this technology, the models that are in use are becoming more and more complex, and they're becoming, or they're requiring high modeling resource requirements. So they're becoming more computationally intensive, which is leading to lengthy analysis times, and this is limiting the potential new applications of PRA. And so in general, the goal of the transition away from deterministic and prescriptive requirements towards more risk-informed approaches is to capture both the economic and the safety benefits of optimizing plant operation by eliminating some of the unnecessary conservative assumptions that these procedures were traditionally based on. And so in general, we're looking for proposals that enhance the applicability, the usability, and also the efficiency of probabilistic risk assessment tools. And so this is a very broad category, and we invite applications from a wide variety of perspectives. But just to kind of plant a couple seeds, there's a few major areas of interest. One is improving the quantification speed and getting around the memory limitations that are required to process very large PRA models. The second is human reliability analysis, human HRA dependency analysis, and incorporating human reliability analysis into probabilistic risk assessment models. And the third is based on the increasing complexity of these models, leading to very complex output and making it more difficult to interpret the output from these models and derive insights from it. And so in particular, non-PRA experts are finding it more and more difficult to interpret model output. And so we're looking for better ways to quantify and take the output of this model, of these models, translate it into information that people can easily understand and act on. In particular, when we're incorporating external hazards into the plant PRA model. So incorporating both of those things into a single model as opposed to modeling the external hazards separately from the plant PRA. Next slide, please. So this slide is just meant to cover some of the ongoing work within the Office of Nuclear Energy on risk-informed system analysis and PRA taking place in the LWRS program. And so some of this work has been focused on developing risk-informed maintenance strategies. So this would be using PRA to assess the risk of failure of different plant equipment, and then using that information to prioritize maintenance schedules. We're also looking at assessing risk associated with digital instrumentation and controls. So many plants are transitioning from analog instrumentation and controls to a digital system, which is introducing software, and in particular, software common cause failure. And we're trying to understand the risk associated with that and how we can use diversity of systems in order to get around that risk or mitigate that risk. We're also looking at fire modeling and simulation for risk assessment, dynamic PRA, which is essentially looking at the time dependency of sequences of events. And instead of treating these as static elements in our PRA models, we're incorporating these time dependencies that can account for things like coping with external hazards or initiating events, and accounting for the plant's ability to respond and not just accept the hazard and assume that failures will occur. So this is, again, like many of the other topics, this solicitation is quite broad. And so applicants are encouraged to propose novel approaches to probabilistic risk assessment, and with the eventual goal of these methods being used by operating plants to streamline any process for which one, PRA is a key feature, so including but not limited to regulatory compliance, but also, as I was saying earlier on the first slide, extending the types of applications that PRA can be applied to. So it's kind of a two-tiered goal here. One is streamlining processes already in use. The second is developing PRA to the point where it can be used for new applications. And so I'm the federal contact for this solicitation. My name is William Walsh, and the technical point of contact is Svetlana Lawrence. She heads our risk-informed systems analysis research in the LWRS program, and she's at Idaho National Lab and should be available to answer questions once everyone else has finished going through their topic areas. And so with that, I can, one more slide. Thank you. And so a couple areas where it may be more appropriate to submit proposals to other topic areas. One is an area that most PRA practitioners are concerned with, and that is reducing unnecessary conservative assumptions. And so while that's an important area, it is more appropriate to submit those proposals to topic area 1, RDO-2, which is more concerned with improving the economics of the existing US light water fleet in general, and also advanced reactors. And so again, topics concerning any improvements to plant economics beyond PRAs and licensing would be more appropriate to submit to that topic area. Also, other topic areas that kind of fall outside of the Office of Nuclear Energy's mission would be anything related to nuclear nonproliferation, nuclear fusion, radiological health monitoring, so personal dose monitoring, anything related to nuclear weapons R&D, medical isotope production, or nuclear medicine related technologies would all probably fall under the purview of NNSA or the Office of Science. And so I guess with that, I will toss it back over to Janelle or Julie. So thank you very much, and I'll be available for questions at the end of the presentation.
Okay, thank you very much, Bill. Now we will move on to LS2, Safety Implications of Utilizing Process Heat by Jason Marcinkowski.
Thank you. I am Jason Marcinkowski. I manage the LWRS flexible plant generation or operation and generation pathway, and we are charged with diversing the revenue for the nuclear plants, as Bill mentioned, and expanding the use of nuclear beyond the electricity grid. So I'm also the program manager for integrated energy systems. So this topic focuses on the use of reliable, low-cost thermal and electrical energy from nuclear reactors to decarbonize industrial processes, such as refineries, chemicals, minerals production, and district heating, as well as the paper and pulp industry as potential industrial processes. We could consider others as well, but they should be of significant scale to warrant a nuclear reactor and national scale impact. Our office is seeking projects that evaluate the feasibility of using the energy from a nuclear plant for decarbonizing off-grid industrial processes. And those activities include the physical, the scope of placing chemical plants with existing LWRs, as well as the co-location of advanced reactors at industrial sites. So we're really looking at the close proximity required for utilization of process heat in an efficient way. So that warrants regulatory research and review for licensing and permitting of these systems. We want the projects to evaluate safety implications for using heat from both existing nuclear power plants and advanced power plants, with work that will develop requirements for mutual protection of each of the industrial and nuclear plants. Impacts of the industrial plant on the nuclear plant and impacts of the nuclear plant hazards on the industrial plant. We want to have the projects engineer conceptual designs to address the requirements as a basis for safety analysis. So coming up with solutions to these requirements that are developed is important. And the safety analysis should both be internal to the project and external as well. So this is something that the results can be pointed to by others as a basis for improvement and growing understanding of what's required for nuclear plants to be safe. And then we want to assess the impacts of both nuclear industrial system maintenance and operations on the system of the nuclear and industrial system. So, is there any interference of those processes between the two industrial and nuclear plant operations. Next slide, please. So our ongoing work includes, as mentioned, the LWRS program primarily. We're looking at hydrogen as our main focus there. And we've looked at the safety of hydrogen electrolysis at 1 kilometer from the nuclear plant. We've got activities and probabilistic risk assessments for assessing new initiating events that are associated with integration of hydrogen. And we've got an industrial engagement process for evaluation of 20 megawatts. Right now it's 20 megawatts of thermal energy applicable to 100 megawatts of electrolysis. And that will likely grow in the future to 100 megawatts thermal energy, at least in the coming year. So next slide, please. So obviously we don't want you to duplicate work that we're already doing. So hydrogen from existing plants should be reviewed prior to submitting the proposal. Most of the areas are identified in the prior slide, so please focus on applications of both LWRs and advanced reactors, but not LWRs that are producing hydrogen. Thank you.
Thank you, Jason. Now we will move on to LS3, Advanced Reactors and Fuel Cycle Facilities, Material Accountancy, Control, and Physical Protection with Savannah Fitzwater and Tansel Selickler.
Thanks. Good afternoon and good morning to those on the further coast. My name is Savannah Fitzwater and I'm the Federal Program Manager for the Advanced Reactor Safeguards or ARS program. So I'll be covering the first half of the LS3 scope today. The purpose of the ARS program is to address near-term challenges that advanced reactor vendors face in meeting our domestic material control and accounting, or MCNA, and physical protection system, PPS, requirements for construction in the US. This work is executed through 6 focus areas, obviously physical protection systems, pebble bed MCNA, liquid fueled MCNA, microreactor PPS and MCNA, and these are combined due to the unique challenges that microreactors face. International considerations, and a new topic for us this year is vendor engagements. So like you've heard in many of the other presentations, one goal this year is to provide more flexibility in topic areas while aligning more closely with our active NE mission work. With that in mind, some areas to consider when preparing applications for the LS3 include obviously identifying the MCNA or PPS approach that you're proposing to develop or expand, considering system response using risk-informed frameworks and probabilistic risk assessment. I'm sure you've heard a theme of risk. The reliability of passive systems and components, and integration with MCNA and PPS measures. You can also consider the advancement of modeling and simulation capabilities to develop, verify, and validate next generation safety, materials accountancy, and PPS codes. You could also consider specifying cross-cutting or interfaces with other topics of interest that you've heard kind of throughout the week. This session is obviously specifically about licensing interfaces, but that could include safety for flexible plant operations, cybersecurity, you heard Becky just a little while ago, physical security, MCNA, plant automation and modernization, human-machine interface challenges, and kind of, you know, a broad list there. It's not meant to be comprehensive. Next slide, please. Thank you. So the ARS program has ongoing research through many venues, including obviously directed research, NEOP, and our small business vehicles. So some examples of ongoing work across each of the focus areas I mentioned just a minute ago include PPS work to reduce the number of on-site responders, PBR MCNA regulatory framework, the approach, that's really a new space we're trying to flesh out. Microreactor, physical security, and MCNA that's appropriate for the very small scale. Like I mentioned, microreactors have a unique set of challenges that we're hoping to address. Liquid-fueled MCNA measurement techniques and technologies, and international safeguards interfaces. So, as you've heard, this is not an exhaustive list of R&D examples, and it's just meant to help kind of provide guideposts on to avoid duplication of previous or ongoing research. So more information about our recent work is available at the newly launched ARS website on the URL provided on the slide there. To reiterate, our goal is for applicants to propose new technologies and techniques that go beyond traditional MCNA and physical security approaches for advanced reactors, SMR, and microreactors, kind of the full gamut of everything moving forward. Next slide, please. Like the other presenters, I want to emphasize that there are some areas that are not of interest for the LS3 approach. So obviously, application should focus on research that supports the DOE NE mission. There's a list of topics that are not applicable on the slide, but I want to specifically draw your attention to the first three, because that's where we often get questions. So we're not looking for proposals on international safeguards and international security, nuclear nonproliferation purposes, or nuclear forensics. We're really looking for domestic applications for MCNA and physical protection. But applications on technologies that cross-cut any of these areas could be considered if the proposal clearly demonstrates the application and explains how it ties in to NE's mission space in the ARS program. So that was short and sweet, but it concludes my slides. I will, like the others, be happy to take questions at the end of the session, and we'll also have Ben Sapedi, the ARS NTD, available as well. Tanzel, over to you.
Thank you, Savannah. Good afternoon, everybody. I guess I should say good afternoon to everybody who joins us from the East Coast. Good morning to the West Coast, and good day to the Midwest. My name is Tanzel Selekler. I am the Federal Program Manager for the Materials Protection, Accounting, and Control Technologies Program, MPACT in short. I am in this position about 6 months now. Given that I am relatively new, I asked our National Technical Director, Michael Brown, and his deputy, Colin Carroll, to be with us during the questions. So please do not hesitate to ask any questions you may have at the end of the presentations. We are in the Office of Materials and Chemical Technologies, NE43, under the Nuclear Fuel Cycle and Supply Chain Office, which is NE4. So please note that we are still covering the LS3, Advanced Reactors and Fuel Cycle Facilities, Materials, Accountancy, Control, and Physical Protection. This is a unique work scope. I believe it is the only work scope which includes 2 topics. Savannah covered the advanced reactors, and I will cover it for the fuel cycle facilities. Materials control and accountancy spans the entire fuel cycle. I included this chart for you to see the entire fuel cycle from front to back end, and also to show you our program focus areas. So the yellow boxes are MPACT program interest areas, and green box is advanced reactor safeguards, which is Savannah just covered. And the colorless plain color boxes mean no current MPACT program interest in those areas. So these presentations will be posted on the NIAP website after the webinars, so you will have more time to review this chart. Next slide, please. Advanced fuel cycles and advanced reactors have unique safeguards and security needs. Traditional nuclear materials accountancy is not always possible or applicable to advanced reactors and fuel cycle facilities. Impact program was initiated back in 2010 to support domestic advanced fuel cycle technology developers to address and meet nuclear materials control and accounting requirements. We do research, we do develop, deploy, and demonstrate innovative technologies, analysis tools, and advanced integration methods to enable domestic nuclear materials management and safeguards for emerging nuclear fuel cycle technologies and for the front and back end of the US nuclear fuel cycle. So what we are looking for? We are looking for new and novel approaches to improve the efficiency and effectiveness of safeguards and security systems, and also new and innovative materials control and accounting technologies, methods, and tools to increase the accuracy, reliability, and efficiency of nuclear materials quantification, nuclear material tracking capability in fuel cycle facilities, and processes and process monitoring tools. Applications need to identify the MCN A type which you are proposing to develop or enhance. Also, please specify all potential fuel cycle facility applications as well as operational constraints. Next slide, please. AMPAC program has ongoing research through directed research, NEOP, and SBIR, STTR funding opportunity announcements. To avoid duplication, applicants should review previous and ongoing research related to AMPAC program to identify the R&D gaps. Unfortunately, MPAC program doesn't have a website I can refer you to like the other programs. We are hoping in the future we will have one. But just to give you an idea what kind of research areas we are currently working on, we worked on in the past. The list of research areas included process monitoring for MCNA, radiation detector development, nuclear material accountancy modeling, physical protection system modeling, data analysis and integration, molten salt elemental and isotopic composition measurement systems, optical analysis methods for elemental and isotopic composition, and argon hot cell gamma spectroscopy. Please note that this list is not a comprehensive list by any means. You are not limited to these topics. They are provided to give you guidance about our program's interest areas and focus areas. You are encouraged to propose any technology beyond the traditional materials control and accountancy methods and techniques for fuel cycle nuclear materials accountancy challenges. You can find previously funded MPAC NEOP projects on the NEOP website. However, it is very hard to find the awarded SBIR, STTR projects lists. If you have any interest, please reach out to us through our integration office, and we will get you the list of awards have been made through SBIR, STTR for. Next slide, please. What we are not looking for. Like Selena mentioned, it is the pretty much the same list. We are not interested in non-proliferation purposes. We are not interested in nuclear forensics, technologies solely for nuclear fusion applications. We are not looking for personnel dose monitoring on nuclear weapons related R&D or medical isotope production or nuclear medicine related technologies. So like everybody else mentioned before me, the applications must support NE's mission. Any crosscut between these technologies could be considered responsive if you demonstrate your application directly related to nuclear energy. That's all I have. Now we can move to LS4 to Janelle. Janelle is going to cover advanced reactor licensing topics. Thank you.
Thank you, Tanzel. So LS4 covers advanced reactor licensing topics. Just to provide some background, establishing the regulatory requirements along with the supporting technical justification have consistently been identified as items that need to be addressed to enable us to efficiently license and deploy advanced reactors on the scale that we need to support our ambitious climate change goals. So to that end, we are seeking proposals for activities that will help address technology-specific gaps in licensing technical requirements for advanced reactors. Also, any activities that would help to reduce the regulatory risk for advanced reactors would be considered responsive to LS4. And I do expect that most of the activities that are proposed would be research related. But if you have any innovative ideas on modernizing the regulatory framework to make it more applicable to advanced reactors, or if you have any innovative ideas on addressing key policy issues that have been identified as needing resolution, we would definitely be open to those activities as well. And this subtopic, it's purposely been written to be very broad. So we encourage applicants to think expansively and to suggest innovative ideas and solutions. And then before I move on to the next slide, I do want to clarify that we are interested in activities that would support any advanced reactor design. So either light water SMRs or any of the non-light water reactor concepts. Next slide, please. So this slide covers some of the ongoing work within NE that's relevant to LS4. First, we have the Advanced Reactor Regulatory Development Program. And with that program, we coordinate very closely with the NRC and with industry to resolve key regulatory framework issues that directly impact the critical path to advanced reactor demonstration and deployment. And through that program, we're supporting advanced reactor regulatory development with a two-pronged approach. First, we're working to develop a cross-cutting regulatory framework for advanced reactors. And we're doing that by helping to resolve high-impact NRC policy considerations. We're adapting LWR-based regulations and guidance to be more applicable to advanced reactors. And we're also working with industry and working with the NRC to establish clear expectations for license application content and review criteria. Then moving on, we have the Advanced Reactor Technologies, or the ART program. And with that program, we're supporting activities to reduce the technical risk for these innovative non-light water reactor concepts. So in this program, we conduct essential research to support fast reactors, molten salt reactors, gas-cooled reactors, and microreactors. And then in addition to these two programs, we're also supporting cost-shared partnerships with industry. And the two ARDP demonstration projects, as well as the CFPP project, all include NRC licensing to get to that end goal of operation. So these demonstration projects are really going to have a significant impact on reducing the regulatory risk for advanced reactors. And then in addition to those demonstration projects, we're also funding activities to reduce technical and regulatory risk for a broad set of advanced reactor designs through the ARDP Risk Reduction Awards and the ARC-20 Awards. And then the last thing I wanted to mention on this slide is that the list of ongoing work is not meant to be all-inclusive, and it's just being provided to assist applicants in identifying research that's not duplicative of previous or ongoing work. We also hope that this list will help to spark some innovative ideas. There may be something that we're already supporting in our programs, but you might have a different and better approach to it. So please feel free to submit those types of ideas as well. I would just recommend that you explain in your application why your idea is not duplicative and how it's different from currently funded activities. Next slide, please. This slide lists 2 areas that would not be of interest under this subtopic. And most of the areas stated by the previous presenters would also apply, but I did want to focus on these items since they're most relevant to this scope. So we would not be interested in activities that only support licensing of nuclear fusion applications, since that mandate is covered by the Office of Science. And then activities that only benefit the existing fleet would be a low priority for this subtopic. We are trying to reduce the regulatory risk for advanced reactors with this subtopic, so your proposed activities must show some benefits for advanced reactors. I would note, however, that if your proposal is cross-cutting and it does support one of the non-relevant areas, but it also supports advanced reactor licensing, then it could potentially be responsive to this subtopic. Next slide, please. So just really briefly, LS5 would cover any of the proposals that are relevant to the overall goal of licensing and safety topics for the existing fleet, advanced reactors, or fuel cycle facilities, but are not covered by LS1 through 4. And it is important to note that any of your submissions, they can't be cross-cutting, but they must support the any mission and at least one of the 4 goals that are listed here on the slide. And with that, we can conclude the presentations on topic area 6, and I believe we're going to open it up to questions.
Thanks, Janelle, and all the other presenters. Yeah, we have a couple questions, and just to make sure everyone understands, if you do have a question about any of the work scopes that were presented, please go ahead and type that into your control panel, and I can ask our federal points of contact your questions. So right now there are 2. I will start with the first question for LS2, and that question is whether thermal electric energy harvesting technology is relevant to work scope LS2.
My inclination is no. This is more for, because those devices tend to be pretty low efficiency, so we're talking about directly using the thermal energy from the reactor in this topic.
Okay. The next question is geared towards LS3, and that is whether radiation detector development is relevant to this work scope.
For fuel cycle facilities, if it's a personnel dose monitoring, no, it is not. However, if it is going to be used for any kind of nuclear materials control and accountants requirements, yes.
Thank you, Tansel. And a follow-up to that question is, what types of radiation detectors might be most relevant?
If Mike is on, Mike maybe can.
Yes, I can tackle that question. So as far as radiation detectors are concerned, we are interested in gamma spectroscopy. We are interested in alpha spectroscopy. We are interested in neutron coincidence and multiplicity counters, the traditional workhorses for accountancy type detectors. But I would also say that beyond those traditional approaches, we're also interested in detectors that can operate in extended harsh environments, such as argon hot cells, high radiation environments where high radiation is probably greater than 1,000 R per hour. And in that case, we would be interested in relaxing some of the spectroscopy requirements or go to low resolution, as long as in your proposal process, you explain how this could be used for nuclear material control and accountancy purposes. For example, if we were trying to track material in a hot cell, something like a gamma camera, or the ability to monitor the movements of nuclear material throughout the hot cell as it goes from unit step operation to unit step operation, are all things that we would be interested in.
Thank you for that, Mike.
Hi, this is Jason. I wanted to clarify on LS2 just in case there's any confusion. When I refer to thermoelectric devices, I'm talking about the solid state devices. If the question is referring to a thermoelectric device as in a generator, a turbine and a generator combination, we are looking at the safety implications of pulling heat off of any section of the turbine, if that's what they're referring to. That would be within the scope.
Okay, thank you all for that answer.
Julie, this is Savannah. I just wanted to ask if Ben had any additional thoughts on detectors for ARS before we move on.
Yeah, I guess I should just say that, we are interested in anything related to improving MCNA for advanced reactors. So, the main thing is just where there are specific cases of advanced reactors where, we would need to do measurements for quantifying actinides. The kind of more specific areas right now that we're doing some work in is burn-up measurements for pebbles, for pebble bed reactors, and then also measurements of molten salts for the molten salt reactors. So mainly just looking at any technology that makes it faster, better, cheaper, as well as improves the measurement uncertainty. Yeah, there'd be interest there.
Okay, thank you all. The next question is if educational activities under workforce training would fit within the LS1 work scope.
That is a good question. I hadn't really considered those types of activities. These are more, I would say, my initial response would be no, and this is more focused on improving the usability of the models. I suppose to the extent that the models are, I guess a similar focus area would be looking at interpreting the output from the models. Maybe that could fall under workforce training, but my initial reaction to that question would be probably not.
All right, thank you.
And I'll invite Lana to maybe add input if she has any other comments.
Yeah, I would agree with that, Bill, that we're not looking for training purposes on this scope.
Thank you.
Okay, thank you both. The next question is for LS1, and it is asking if you expect a probabilistic risk assessment software as a deliverable for this work scope, or is it expecting improvements to existing PRA software like Sapphire, for example?
It could be both. We were looking into improvements of existing tools rather than develop a requirement to develop a new tool. However, if you propose a new tool that is significantly better than Sapphire or CAFTA or some other tools that are currently available, I would think that would be a possibility.
Svetlana. And that concludes the questions.
Hey everyone, I want to thank all of our presenters here in this section today. We really appreciate all your information.